Hello everyone. Today we'll be continuing on our topic of multinomial theorem. So in our last session on multinomial theorem, we talked about multinomial theorem and how the multinomial theorem is established. So today in this video, we'll be trying to solve a question from the multinomial theorem topic so that you can get an understanding of how multinomial theorem questions and how it is solved. So let's begin with the question. I have already prepared a question for you. So the question is a fairly an easy, very easy question, is that we need to find out the coefficient of x square y5 z cube in the expansion of, I use shorthand in most of the time, so as you can see expansion I have written in short over here, so don't be confused. So by this I mean expansion of twice x plus y plus z whole to the power 10. So I need to find out the coefficient of this very term in the expansion of this thing. So let's proceed. First of all, let us try to find out the general term in the series of twice x plus y plus z whole to the power 10. So let me write it down. Twice x plus y plus z whole to the power 10. So what does this come down to? So this will basically come down to summation. We have here 10 factorial by r factorial by s factorial by t factorial, and then we have twice x to the power r, then we have y to the power s, and then we have z to the power t, and also there is a condition that r plus s plus t must be equal to n, where n is here is 10. One more thing that I want to point out to you, that if we add out the powers of x, y and z in this very coefficient that we need to find out, then you can see that 2 plus 5 plus 3, this is equal to 10, and as such I think that we can find out the coefficient of this very term in this expansion. So that is one try out that there will be some problems in which this power is not equal to 10. In that case you are told that you need to find out the expansion of that very term in this expansion, so that will not be possible since their addition, that coefficient does not exist in this expansion. So that is the thing that I want to point out to you. So let's begin. So this will ultimately give us rise to the structure of summation 10 factorial by r factorial by s factorial by t factorial. Now this will give us 2 to the power r into x to the power r, y to the power s, and z to the power t, subject to the condition that r plus s plus t is equal to 10. So as you can see over here, if we put r equal to 2, then s equal to 5, and t equal to 3, then we get this coefficient, and that coefficient and the coefficient of x to the power r, y to the power s, and z to the power 3, which will be ultimately x square, y5 and z cube, will be equal to this thing where we'll put r, s, t as 2, 5, 3 respectively. So therefore here, let me write it down over here r is equal to 2, then we have s is equal to 5, and then we have t is equal to 3. So therefore we can write that required coefficient will be equal to, we have factorial 10 in the top, then we have factorial 2, factorial 5, factorial 3 into 2 to the power r. 2 to the power is basically 2 square. So this is the structure. We need to solve this structure. This will take some time, but ultimately you know that the process has ultimately come to this format. So this will be equal to 10 into 9 into 8 into 7 into 6. So 5 factorial cancels out on both top and below, and this will be 2 into 3 into 2, and we have 4 over here. So this 3 and 2, 6 cancels out, and then we have 2 and this will cancel out. So this will be ultimately equal to 10 into 9, this will be 90, 90 into 8, this will be 720, 720 into 14 is what we're looking for, 720 into 14. You need to solve this, and finally you will get an answer accordingly for the coefficient of x square, y to the power 5 and z cube. So this is the way in which you approach the problems for multinomial theorem sum. So I hope your understanding of multinomial theorem is much more clear after solving this sum. In any other case that you have any difficulty solving this problem, or you have any difficulty understanding some other problem regarding multinomial theorem or any concept regarding to multinomial theorem, then you can comment in the comment section below and we'll try to get back to you. All the best for your preparation. Thank you very much.